Before we start the video, let me give you a brief introduction about myself. I'm Chandresh Mahajan, who is founder and chief educator at Exergic, which is India's most trusted and comprehensive institute for online gate preparation. I got an All India rank 37 from Gate Mechanical Engineering, and I am an ex Indian Oil officer, having 6+ years of teaching experience as of now. To know more about our GATE courses, you can contact us on these details. Also, you can download Exergic GATE preparation app from Google Play Store. The link is available in the description of video. So till now, we have covered two different ways to solve velocity analysis questions. The first way, I would call it the Exergic way. You will see it very soon why I call it that. It includes the basic concepts. Right? Like the concept V is equal to R omega, like the concept of rigid body that I told you, and such similar concepts. The other way was using the I center, right? Using IC method or I center method. Now we are going to cover two more ways to solve the questions of velocity analysis. Third one is going to be graphical method. It is again a useful method. And last one is vector notation method. Before I proceed and tell you more about these 3 and 4 methods, and we are going to solve a lot of cases. Before that, I want to tell you that you can use any of these methods to get the answer. There might be some cases where any of these methods may not work, any of these methods may get stuck, but in most of the cases that you are going to get in your exam, any of these methods you can apply to get the correct answer. The only difference will be that one method may take some seconds more and the other method may take some seconds less, but answer is going to be same. You are going to get the answer. Even the method 1 and method 2 that we have discussed already, I am going to talk more about them. When I am going to compare all of these, I am going to talk more about those two methods as well, which we have not covered. And trust me, once we are done revising the two methods and covering these two new methods, especially this third one, you will be able to solve 100% questions of velocity analysis with accuracy. I hope the spelling of accuracy is correct. And with confidence. Because if the spelling of accuracy is not accurate, then it will not be a good thing. Anyway, jokes apart. So, with accuracy and with confidence, you will be able to solve all 100% velocity analysis question, no matter how simple or how complex the question is. So, let's do one thing. Since we have covered these two things, we know the basic concepts, we have covered the IC method. Let's cover the graphical method first. And this method is very useful. Trust me, it is a very useful method. And there will be some questions which you will be able to solve very quickly using graphical method, although it may sound somewhat complex that what graph is to be made and what diagrams need to be made. But there are certain questions which can be very quickly solved using the graphical method as compared to other methods. The fourth method, let me brief you about it. Let me give you an overview before, is not a popular or the best method, I would say, because it is slightly lengthy. You need to write all the notations as per the selected axis, and then ultimately you get the same answer, but 2-3 extra steps are involved into this. And especially when the mechanism is somewhat complex, then vector notation method may get lengthier. So method 4, the fourth method, is not the method that you will see in most places. This is not even taught in most places, and it is not recommended a lot. But still, nothing is totally bad. There is one thing which is very interesting and very useful tip that you can learn from this method. Just like this tip I gave you of rigid body. and how you can use the funda of rigid body to solve the questions of velocity analysis. In a similar way, I will give you a funda here in vector notation method, so that you will be able to solve good questions of angular velocity analysis where angular velocity is required, right? So don't worry, we are going to cover all of them, and as I told you, you will be a master in velocity analysis once I will complete the rest two methods, and I will tell you some more things about these methods. In the end, I will also tell you one thing, that what method you should apply in what preference. You have a velocity analysis question, from which method you should start. If you find it lengthy or you don't know how to proceed with that, which method to select next, and things like that, I am going to share with you, not only for linear velocity analysis but also for angular velocity analysis. So let's start discussing graphical method first. Now let us start the graphical method with the most basic case. This is the case which is the most fundamental case for velocity analysis. Let's start with this, and then we will move on to more complex shapes and more complex mechanisms as we cover the basics. Now, the graphical method includes the construction of velocity polygon. Okay. What we do is that we draw a polygon. Okay, we draw a polygon, like a triangle is a polygon, a square is a polygon, any random vector arrangement is also like this, can be called as a polygon, and all of them are closed together. They are not forming, a open shape, they are forming a closed shape. Whatever they look like, they may look like this or like this, whatever be the shape, this can be called as a velocity polygon if, point number 1, the vectors used, they denote some velocities. It may be the velocity of point A, of point B, or of any other point. Or secondly, it is a closed polygon, right? Now, strictly speaking, velocity polygons are drawn to scale. What does it mean? It means that if I have represented any vector of velocity by a straight line like this, and I tell you that this vector is of let's say 5 centimeter length, it is of 5 centimeter length, and it represents the speed of 5 meter per second. Okay, I have drawn this vector. Obviously, I will draw it for some velocity. Maybe the velocity of B, this vector B, this point B is equal to 5 meter per second, let's say. So I have drawn this for to represent the velocity of B, which is equal to 5 meter per second. And suppose I have drawn this vector of 5 centimeter length. Then what is the scale of this vector? In this vector, 1 centimeter represents 1 meter per second, right or not? If this is 5 centimeter, so it is 5 meter per second. If this was 2 centimeter length, then the speed would have represented 2 meter per second. So accordingly, I have set one scale, and this scale will be applicable for any other velocity that I draw with respect to this velocity. For example, if on the same graph, on the same sheet, I want to draw the velocity of A as well, and let's say it is having some other direction, it is in some other direction altogether, right? Then what is going to be the magnitude of A should go in hand with the length of this vector. If the velocity of A is 3 meter per second, then I have to draw a vector of 3 centimeter. I cannot draw a vector of random length like this, and then I can say that this is VA is equal to 3 meter per second. No, it is incorrect. It looks longer than this one. If this one was representing 5 meter per second, its length was 5 centimeter, then how come a vector longer than that can have only 3 meter per second speed? Its speed should be higher than the 5 centimeter one, right? So length and the speed which the length is representing should be coherent, they should be consistent. You cannot randomly draw any length and say that this velocity is now equal to this much. You cannot draw va like this and then say that va is equal to 10 meter per second. It is incorrect. If its length is 1 centimeter, then it will be representing 1 meter per second and not 10. If you want to show 10 meter per second velocity, then draw a vector of 10 centimeter length. then it will represent the velocity of 10 meter per second. You're getting the point? These are the basics, and it is very strictly applicable for velocity polygon. Now, I'm very sure that a question will come in your mind that, sir, how come we are able to solve such questions, and why even should we practice such questions? Because in any of the competitive exams that you are going to write, they are not going to allow you the scale with you, right? You cannot draw the velocity vectors as per scale. And also, whatever angles will be there, suppose the angle between two vectors should be 40 degree as per the question given. Now we will talk about it later, that how angles are decided by the given mechanism. But suppose that two vectors are to be drawn by 40 degree angle between them, then you cannot randomly have any value of this angle. You cannot draw them like this and then use it as 40 degree, or you cannot randomly draw it like this and use it at 40 degree. You have to draw it exactly at 40 degree in order to solve the question with the right answer. So you don't have any tools with you to measure the lengths, to measure the angles. Then how come you are able to solve any question using velocity polygon? This is something that you should not be knowing, right? No, it is not the case. To draw the accurate velocity polygon diagram, obviously you are going to need the scales. If I want to draw exact velocity diagram, and I want to find out the answer by measuring the velocities, then obviously I will be needing all the equipments which are needed to draw any diagram geometrically accurate. But for the study, for the questions that we are going to solve, the good thing is that even the inaccurate velocity diagrams will give you the accurate answer. Even the inaccurate velocity diagram will give you the accurate. I don't know what is happening. I am not able to write the accurate spelling correctly. So even with the inaccurate velocity diagrams, you will get accurate answer. You will get accurate answers. And when I say inaccurate velocity diagram, I do not mean that conceptually it is inaccurate. Conceptually, it should be accurate, it should be correct. But it can be inaccurate in terms of scale. I can draw VA to be same length as VB, but I can claim that it is 3 meter per second. It is not going to affect my answer. That is how we are going to solve it. So, conceptually, it should be accurate. We are going to discuss the concepts, but scale wise it can be inaccurate. It will not matter. You will get perfectly accurate answer using the velocity polygon method, even without using any of the scale, any of the protector to calculate or to find out the angles. These are the some introduction about the velocity polygon. I have not started velocity polygon yet. We are just covering the introduction of velocity polygon method. Now coming to the discussion of velocity polygon, the graphical method of solving velocity analysis questions. So there we have the velocity vector for all the members. For example, OA is a member. OA, you can see, is a member. This is a member, right? Similarly, AB is a member, right? AB is a member. Similarly, this point B or this slider is also a member, right? It is a different member which is connected to AB. So we have different members which will be having different speeds. OA, in this case, A point will be having certain speed. There will be different points along OA. All those points will also be having a certain speed, right? It will vary as V is equal to R omega. This is the center. R will be the distance of the point from O, and omega will be the angular velocity given to us. So using that, you can find out the velocity of any of the point on OA. Similarly, AB will also be having velocity. Different points on AB will also be having their own velocities. Also, it is possible that this AB, will be having some angular velocity as well. It might be doing some angular rotation about some eye center, right? So, different types of velocities of different points are available in any of the given mechanism. Now, what we are going to do in velocity polygon, we are going to represent their vectors. Now, how we are going to do that? Let me show that to you very systematically. Let's talk only about OA right now. Forget all other members of this mechanism. Just think about OA. If you have a rigid link, OA, and you are sitting on point O, this is where you are sitting, okay? And you will look at point A. You are looking here at point A. What is the possible direction in which you will see this point A moving? I have asked you this question already. I have explained this funda to you already, that if you are sitting on O and you are looking at point A, then in what direction you will be able to see the point A moving. That is something that I have taught you already. Since OA is a rigid link, the point A cannot move towards O or cannot move farther from O. Also, it cannot have a velocity in any such direction where the component of its velocity will be along O. It is not possible, otherwise it will be the same thing. I cannot say that it will be acting at this angle, at an angle of 60 degree from OA, because it will be having a component along OA. It cannot have any velocity component along OA. The velocity along OA should be zero, direct velocity as well as the component of any velocity, because O and A, the distance between them cannot change with time, they are rigid link. So the only possible direction for point A to move with respect to O, I am saying, is perpendicular to OA, because in that case the velocity component along OA will be 0. It is 90, cos 90, 0, right? And remember, it is not the absolute velocity of A, it is the relative velocity of A with respect to O. It is possible that A may be moving in some other direction, but with respect to O, means when you sit on O, it will look as if A is going only in this direction to you. So it is the relative velocity of any one point on a link with respect to any other point on the link, be it A or be it O. This point can be different, this point can be this point also, B point also, this O can be this point C also. There also this funda is valid, that velocity of B with respect to C will only be perpendicular to BC. Okay, now coming to the discussion, if OA is a member where you can only have the velocity of A with respect to O perpendicular to OA, then definitely the vector of that velocity will also align in that line, right? If OA is rotating like this, then A will try to move like this, right? This whole link will move like this. Then the velocity of point A is going to be in this direction, correct? And how it will be oriented? Will it be oriented like this or like this or like this or like this? You can simply determine the direction of that vector, of that velocity vector of point A, by drawing a line perpendicular to OA, right or not? Because in that direction only it has to lie. So let us first draw a line which is perpendicular, to OA. Okay, roughly perpendicular. As I told you that although we have to draw a velocity polygon which is as accurate as possible, you cannot randomly draw any vector. Conceptually it should be correct. You cannot draw velocity in that other random direction or in some other direction which is not perpendicular to OA, but it is allowed if you are not able to totally get it at 90 degrees. You will realize it very soon. So this is the line along this line the velocity of A should be going, right? So let us draw a vector representing the velocity of point A. This is the vector which is representing the velocity of point A with respect to point O. So we are using small letters here. Capital O is written as small o, capital A is written as small a. In velocity diagram, it is totally your choice. You can write it as capital O dash, capital A dash also. You can write it in some other notation also. It is not going to change, not going to matter as far as your answer is concerned. Now, this is point O in this velocity the vector. This is point A, and this is moving towards A. So it is telling you the velocity of A, velocity of point A, right? That is why I have written capital A with respect to O, right? Now, O is at rest. In this case, O is at rest. O is not moving. So, velocity of A with respect to O, specifically for this case, is same as the actual velocity of A. If you don't know this funda, write it down in your notes. That velocity of any point, velocity of any point in a mechanism with respect to a fixed point or with respect to a fixed member is same as the actual or absolute velocity of that point. If question asked you what is the actual velocity of point A, actual means if you are at rest, whatever observation we do it at rest. So that velocity is actual or that velocity is absolute. So whenever question asks you the absolute velocity or the actual velocity, it is basically asking you the velocity with respect to you, with respect to any person who is at rest. Point O is also at rest. So velocity of A, the actual velocity of A, which is absolute velocity, is same as the velocity of A with respect to O or with respect to G. This G also is ground, which is fixed, right? So both of them, point O, which is fixed here, as well as G, which is ground, which is fixed here, both of them are treated as the same point, as rest. So you need to define a point, absolute rest point in velocity diagram. Write it down in your notes as well. So write it down in your notes that in the velocity diagram, it is necessary to have a point which represents rest, which represents actual absolute point with respect to which we can define the velocities. For example, in this case, the point is this O. This point can also be called as G. I have put comma here that G means ground, which is at rest. Point O, which is this hinge, which is also at rest. Both of them are representing the same point. This same point is representing zero velocity, right? And since it is at rest, so this velocity vector of A is with respect to rest. So velocity of A with respect to O is same as actual velocity of A. Whenever you have velocities defined with respect to rest, with respect to ground, they are the actual velocities, as I told you. As I told you that you write it down in your notes in case you don't know it. Now, this is the graph, this is the vector for velocity of A. Do we know its magnitude yet? It will depend upon the question. Question may give you the length of OA, that OA is equal to 2 centimeter, omega is equal to 5 radian per second. So in that case, what will be the velocity of this point? V is equal to R omega. R is known, omega is known. You can find out the magnitude as well. Direction, you can clearly see that if this omega is moving in this direction, so VA has to be in this direction, right? So magnitude, you know, so you can decide the length. Since direction also you can decide that it has to be drawn in this direction. And to decide the direction, two fundas we have used. One is that the velocity should be perpendicular to OA. Maybe in this direction, maybe in this direction. But since omega is in this direction, so velocity will also be in this direction and not in this direction. Depending upon the magnitude, we have drawn the length. Since in GATE or EIC or any other exam, you will not be having the scale with you, so any random length you can draw, it is not going to change your answer, trust me. I will show you how it will not change your answer. Now, coming to AB, this may get tricky for you in the beginning, because for link AB, neither A nor B are at rest, right? So you cannot draw the vector from here. You cannot say that AB, the velocity has to be perpendicular to AB. So I will draw a line perpendicular to AB, which is passing through rest, and then I can tell you that this is the velocity vector for AB. You cannot do that because neither point A nor point B are at rest. So the vector will not pass from this point. Vector will pass from what point? This point. This is the point. Now you have already decided the point for A. This small a represents this capital A in the actual diagram. So consider this end to be point A, small a, similar to this point, capital A. Now AB, if you look at it, if you are sitting on point A, let's say, now you consider yourself sitting at point A. If you are sitting at A and you look at B, what will be the direction in which you will see the motion of B? With respect to A, again I am telling you, perpendicular to AB, right or not? Don't think that, sir, how can it move inside the ground, or how can it get lifted from the ground? B cannot move like that. B has to move like this. I know B has to move like this. But this velocity, what I am telling you, is the velocity of B with respect to A, not with respect to rest. If I want to define the velocity of point B with respect to rest, then obviously it can move only in this direction. If you are sitting on ground and you will look at B, you will realize that it can only slide like this, right? But that is the velocity of B with respect to ground, or with respect to rest, or with respect to O or G, not with respect to A. So be very clear in the difference between absolute and relative velocity. That is why I have covered this in the very first, in the beginning of theory of machines, that this difference should be known to you. That when we are sitting at A and we are looking at B, the velocity of B which we are able to see is the velocity of B with respect to the point of observation, which is point A. If point A was at rest, then this velocity would have been the actual or absolute velocity, just like it was in case of OA. In case of OA, we defined the velocity of A like this, but since O was at rest, this became the actual or absolute velocity. But in this case, when we are having link AB, we are sitting on A, looking at B, and trying to draw a line perpendicular to AB to decide the velocity of B. That velocity will be that velocity of B with respect to A. And since A is not at rest, we can see that A and O do not coincide. They are not the same point. A is not at rest. So this velocity of B that we will get perpendicular to AB will be with respect to A and not with respect to ground, and not the actual or absolute velocity. Got that? Now, let's draw a line perpendicular to B, right? And where should that line pass? Here or here or here or here or here? It should pass from here. Why? Because we are defining the velocity of point B with respect to A. So it should pass from point A and not from any other point. So we know two things about the velocity of B with respect to A. One is that since it is with respect to point A, so we have to pass it from point A. And second, it should be perpendicular to this link AB. So let's draw a line which is passing through point A. Let me get it here. Which is passing through point A and is perpendicular to AB. So this roughly looks perpendicular, this line, to AB, and this is going to be the orientation. And then we are going to draw a line like this, right? This is such a line which is perpendicular to AB. Now don't think that, sir, how you can pass this line from there? B, the line perpendicular to B should pass from here. No, it is not like that. This line is obviously perpendicular to AB, and any other line which is parallel to this line that I have drawn will also be perpendicular. So this line also is perpendicular to AB. Don't think that, sir, you have to draw a line passing from B only. No, it is not like that. Okay. Again, a question comes. Suppose question gave you R and omega. So you were able to find out the velocity of A, and you know a definite value of this line. Suppose you calculated that the velocity of A is coming out to be 10. So you have drawn a line of random length, but I have written 10 with it. But in case of AB, I don't know how much is the angular velocity of AB. I'm not in a state to determine that how much is going to be the length of this vector, since it is not given to us. I don't know it. That is why whenever you are drawing velocity polygon, do not randomly draw any vector without knowing the value. Draw any vector only when you know the value of it. Like I have drawn for VA. We exactly know the value of R, or the length of OA, and we know the value of omega. So we can calculate R omega to find out the velocity of A if question has given us the value. So we know the value of VA, so we have drawn a definite vector to represent it. But for AB, we don't know the angular velocity of AB. And even I don't know whether AB is given to us in the question or not, because we are not solving a question, just looking at a general case, right? So even if AB's length was known to us, but since omega is not known, how you can calculate the velocity of B with respect to A? You cannot do that. That is why we have drawn a straight line here, which is not ending anywhere. It is just an infinite line which is passing through A, and it is perpendicular to AB. What we know, that velocity of B with respect to A will be along this line, but whether it will be up to here or up to here or maybe in this direction, we don't know yet. Now, coming to the third link, OA link we have covered here, OA we have drawn, AB we have considered here, although B point is not known to us whether it is going to be, but we have done whatever we could. Coming to third and last link, which is a slider. Slider, if you look at it, it is going to move in this direction, correct or not? And it is going to move with respect to ground. We can clearly see it, right? Its direction we can clearly tell that it is going to be in this direction, in horizontal direction. Also, OA is moving like this. So this point, this slider will get pushed in this direction, right? Because A is coming here. So AB is getting pushed there. So B is getting pushed there, right? If omega was like this in this direction, then slider would be moving like this. Basic intuition you can understand from slider crank mechanism. We have already covered that. So velocity of B is going to be horizontal, point number 1, and it will be in this direction, a horizontal velocity in that direction. And from where it will pass? From ground, the point of ground, which is at rest, which is at same point and O. Write it down in your notes again. All the points at rest, write it down in your notes. Listen to me, pause the video and then write it down in your notes, that all the points which represent velocity is equal to 0 will be drawn, will be shown at the same point. In a graph, there will be a single origin which is going to represent 0 velocity. You cannot have O here and then again you will see that G is here with 0 velocity and then again P is here with 0 velocity. It is not going to happen. All the points having 0 velocity are going to be at the same point, at the same place, represented by the same dot. Got it? Write it down. So we know that the velocity of this slider with respect to ground is going to be horizontal, point number 1. It will be in this direction, point number 2, and it will pass from this point, from the point of rest, right? How? Because it is defined with respect to rest. If I tell this is the velocity of slider, I will ask you with respect to what? You will say that, sir, it is moving like this on the ground with this velocity. So the velocity of the slider was with respect to a link which is at rest. So its velocity is absolute velocity with respect to rest, right? And if we have such velocity, we have to pass that from where? From this point O or G. From that point we are going to pass it, right or not? So it is going to pass from G or O point. It is going to be horizontal and it is going to be in this direction. So this is what we have done here. Now you can clearly see that they are intersecting here, right? Now just pause the video and think, what should be this point? What should I name this point? Don't you think this point should be B? Why? How? Because B is the same point on the slider. B is a point which you can say that it is on the slider as well as on the link AB, right? It is the common point between them. And if slider is moving like this with respect to rest, then B is also moving like this with respect to rest. With respect to rest being the keyword, right? So if slider velocity is represented by this, then obviously the velocity of B will also be represented like this, correct? And the point where these two lines intersect is the common point between them, just like point B. Point B was common in AB and it was also present in slider. So it was the common point of AB and slider. Similarly, this point here is the common point for this AB as well as the velocity of the slider. This is the velocity of AB, this is the velocity of slider. So this point has to be B. Now you can draw it that this is the arrow of velocity of slider, velocity of B with respect to ground, or absolute also, since with respect to ground velocity is same as absolute velocity. And this velocity here is velocity of B with respect to A. This completes your polygon. These details, these lines which we draw here are now not relevant to us since we have completed our polygon. So we are done here. We have completed our velocity polygon. And now whatever is asked to you in the question, you can determine. Maybe the question gave you the velocity of slider and asked you the velocity of B with respect to A. Or maybe it gave you the velocity of B with respect to A and asked you the velocity of B. You can calculate it from here. Again, a question will come to your mind, sir, how we can calculate it? We don't know scale. We have not drawn it to the scale, right? The angle at which we draw this line was very much by assumption that this line is perpendicular to OA and the length of this line is also not drawn to scale. But you don't have to worry. Here, geometry is going to help you. Geometry is going to help you. Because we are not finding out the value of VB by measuring this length. If you wanted to calculate VB just by measuring this length, then it will not work. But if you want to find out VB by geometry, it will definitely work. Suppose this angle is given to you. This angle is given as 40 degree to you. Let's assume. So if this angle is 40 degree and I have drawn a line at 90 degree, then this line will be oriented at what angle? 180. This angle I am asking. This angle. 180 is equal to 40 degree plus 90 degree plus unknown angle x, right? Triangle angle sum property. From that you can calculate the value of x, right? It is coming out to be 50 here. X is coming out to be 50, right? So if this angle here is coming out to be 50 degrees, then obviously this angle will also be 50 and this angle is same angle 50 degree, right? Basically the line which is perpendicular, let me write 40 here, yaar. The line which is perpendicular to OA will make an angle 50 degree with the horizontal. Now, whether this angle is made here or here, it is going to be vertically opposite angle, same angles. So this line here, this line which is perpendicular to OA is going to make 50 degree with the horizontal. Correct or not? This line is horizontal, obviously. And also question will give you some other angle using which you can calculate the orientation of this line as well. Okay, maybe you will be able to find this angle or this angle or this angle. Basic geometry that you have studied for 3-4 years in your schools. Okay, and once you have calculated these angles, suppose you have calculated and this angle came out to be 40 degree, let us say. Okay, and question was asking you velocity of B. It had given you velocity of A indirectly by giving you the length of OA, by giving you omega. So you can calculate R omega. This velocity you can calculate. So this is known to you. These two angles you calculated and now VB is required. So here one rule is going to be important, that in case you don't know, although it is something that we covered in school, but some of the students are not aware of it. So you can use this sine rule to calculate any of the lengths or angles in this triangle if required. The sine rule says that if you have a closed triangle like this, and write it down in your notes if you don't know about sine rule. This is angle A, this is side A, let's say this is side B, this is side C. Angle opposite to side A is capital A. Angle opposite to side B is capital B. Angle opposite to side C is capital C. Then in such case, sine of A, angle A divided by the side A is equal to sine B divided by B is equal to sine of C divided by C. Got that? You apply it here, you will get that sine of 50 degree, this angle, divided by the side opposite of it. What is the side opposite? VB with respect to A is equal to sine of 40 degree divided by VB. Sine of 40 degree divided by VB is equal to sine of this angle, which is coming out to be 90. Since we hypothetically wrote any angle, so somehow it is coming out to be 90, although angles may be different. Okay, so that is equal to sine of 90, this angle, divided by the side opposite of it, which is VA. So you see, if you know two angles, you can calculate all angles. Third one can be calculated. And any of the velocities are known, the other one can be calculated. If suppose VA is known to you, R omega is given, VA is known, you can equate these, right? And you can find out VB since VA is known. If you want to find out the velocity of B with respect to A, then you equate this one and this one. You will be able to calculate VBA, right or not? This is a rule which is going to be very useful for you in this velocity polygon method. Write it down in your notes if you have not written it. Suppose if I ask you, just let me randomly ask you one thing. Although we are going to separately cover the calculations of angular velocity, this is not something that generally it is done anywhere. They simply tell you all the velocities in one go, but we are going to separately cover the angular velocity as well. That how you can do the calculation, what are some tips to be used there, and in what order you should try different methods for angular velocity. Everything we will cover. But suppose it asks you the angular velocity of this link AB or BA. Both are same. We know that V is equal to R omega, or omega is equal to V divided by R, right? So if we go by the same expression, we can find out the angular velocity of this link by dividing the magnitude of velocity of B with respect to A with the length of AB. This is equivalent to V, this is equivalent to R, and it is going to give us the omega. Now, there are more things to talk about this expression, which we will be doing. As I told you, I just asked you this question because it just came to my mind. Because some of the students right now may be able to understand that why we have written this or how we have written this, which is very good. Good job. And if you don't understand this expression, that how it came, why we write it like this, do not worry at all. We are going to separately cover, as I told you, angular velocity and its calculation, how you can calculate angular velocity. That is going to be separately covered with different methods to calculate it. There will be some additional tips also that I will be giving you to quickly calculate angular velocity in just a single or two steps. So this will also be discussed there. This expression, how to use, where to use, will be separately discussed in detail. So just relax if you are not able to understand this. But this is also something that can be calculated from this diagram, because you can calculate VBA, right? Velocity of B with respect to A. The magnitude of that can be put here and divided by the length of AB if it is given to you. And it can help you in calculating the angular velocity of this link AB. You're getting my point? Now let us talk about this diagram, that why, even being geometrically inaccurate, because the angles are not proper, the orientations are not proper, we have just drawn it intuitively by feeling that okay, if O is like this, then and O is fixed, then the velocity of A should be in this direction. So we have just drawn a vector like this, right? Without even knowing whether it was actually perpendicular or not. But still we are able to get the answer. You look at this angle. This angle was coming out to be 90 degree. But clearly this and this are not perpendicular. 90 degree should look like this. So the diagram that we have drawn is not geometrically correct. But still the answer that you will get by applying the sine rule in this triangle is going to give you exact and correct answer. Suppose the question asks you to find out the velocity of B. There are two ways of doing it as far as this method, this polygon, velocity polygon is considered. One way is that you draw the velocity polygon and then you measure this length. And obviously, when you will draw the velocity polygon, you will set a scale that 1 centimeter is equal to 1 meter per second, let's say. You will obviously set up a scale accordingly. You are going to draw this vector va, right? Of if va was 5 centimeter, then va represents 5 meter per second length. Similarly, if vb comes out to be 3 centimeter, then you will say that the velocity of b is 3 meter per second. This is one way. Obviously this way is not going to work in any of your exams. The other way is applying such rules like this, which do not depend upon whether your diagram is made accurate or not. It just want the value of A, angle A and side A. It does not matter whether the diagram that you have drawn looks like this, or maybe it looks like this, or maybe it looks like this. All these three triangles are different, but the answer that you will get will be same, because it does not depend upon the actual diagram. It just depends upon the values of angles and the values of the sides a b c, and these sides you directly use as per the data given in the question. You don't find out the values of the sides by measuring them, right or not? You use those values because they are directly given to you in the question, or you calculate them like you calculated va by r omega mathematically without depending upon the scale, without depending upon the geometry. That is why even if you draw the diagram incorrect, it is not going to matter. You are going to get the same answer. But there is one very important thing to understand here, that always draw the diagram as accurately as possible. What I mean to say is that if this is link OA and this is how it is rotating, so VA should be in this direction roughly. So if I was having a pen and paper, I will draw like this. I will draw it like this. Oh, this is as A and this is VA, which is logical. But if I draw VA like this, for the same case, if I draw VA like this, that sir told that diagram does not matter. Let's draw it anywhere. Some will draw VA like this. This is O, this is A, this is VA. Now, this is blunder. This you cannot do. If you will do this, there's no guarantee that these two lines are going to intersect and give you a point B, right? You need to be little bit logical, little bit accurate. You cannot be totally incorrect. So don't randomly draw any arrow anywhere and then say that sir told that inaccuracy does not matter. So don't do these blunders that randomly you will draw a line, you will put the pen on paper and then drag it anywhere. Don't do it like this. Be somewhat logical. Look at the shape of the link given and think that this should go like this or like this, and try to draw it as accurate as possible. You may draw it like this or like this or like this or like this. All of them are going to get you the answer. But if you draw va like this is O, this is A and this is va, and you will say this is going to go like this, it will be very difficult for you to get the answer correctly. So let us solve an example, a basic example from this, and then we will see some advanced cases, some advanced links and mechanisms where it will not be this easy. The velocity diagram will not be this easy, and there are certain more concepts to be discussed here. What if I want to find out the velocity of a point which is on a link, not necessarily at the end, but between the link? How to find out that velocity using the velocity triangle? What if there is some other link which is connected to this link, and that other link is also having a slider like this? How do I include that into the velocity triangle? So there are more things to know, more things to learn, Let us start taking small steps. Let's start with a very basic question, basic solved example. Now have a look at this simple question. Question says that you have a link AB which is connected to link BC as shown here, and there is a slider at the end C. This is not something which is written in the question. This is something that you can understand directly from the question, right? You can see that AB is having an angular velocity omega AB in this direction, right? You can see this arrow, correct? And obviously, since it will be moving, BC will be moving, C will be moving. So whatever orientation we have been shown will keep on changing. Whatever angles, whatever positions are visible to us, at every instant they will be changing. So this case, what has been given to us, or any case of velocity analysis that we see in the questions, is given for any instant, at any instant. For every other instant, the angles, the orientations will change, the position of the slider or of these members AB and BC will change. So everything in the link will change. So velocity analysis is done for any particular instant. Clear? The question has given you the length of the links. AB is 5 meter, BC is 4 meter. And what is the orientation of AB from the vertical, or you can also say from the horizontal, because if you know this angle, you can find out the other angle as well. So the orientation of link AB and BC is given to you in the question. What about this slider C? It has given you that this is moving with a speed of 12 meter per second in the upward direction. There is one thing I want to share with you. Generally, the arrows that we see, we think that these arrows are merely a shortcut to say that it is moving in the upward direction. So rather than writing upwards, the question just draw an arrow in the upward direction. It actually represents the upward direction. Don't think that it is just a shortcut which I have written here to replace the word upwards. Don't think it like that. It is actually used in questions. It can actually come in gate where a question will be given to you and the direction can be shown by an arrow. Gate has not asked any question on this yet. It clearly mentions the direction, but it does not mean that it cannot ask such question. If a direction is mentioned, is given to you like this, it means that it is going in the upward direction. Do not ignore these signs if these are asked. So if 12 meter per second is the velocity of C, upward arrow means in the upward direction, it is moving in this direction. So it is asking you that determine the angular velocity AB, this angular velocity of link AB, that you have to determine. Okay. Now you can do it from different methods. I have already told you that it is not like that you only have to apply the vector method or the eye center method or the general method that I have told you. You can get the answer of this question by any of the methods. All the methods are going to get you to the answer. Only difference being that some method may be quick, some method may take few seconds extra. So one thing you need to understand right now, that don't panic if you are not able to understand any method well. Although I will not recommend it, I will recommend that you try and be expert in all the methods. What some students or some places recommend, that just master any one method and apply that method only everywhere. Do not do this. For example, this question which I have given you, when I will tell you the vector notation method, you will realize that this question you will not be able to solve easily using that. Okay, vector notation method will not be easy in this case, and you will get stuck in the question. Similarly, there can be some cases where the eye center method, where you have to locate the eye center, that may not totally work because all the angles or all the dimensions might not be known to you. To locate the eye center, you need different dimensions, right? We will solve such question. I will show you a question where the eye center funda will not be totally applicable. I will show you that question. Okay, so my recommendation is that you know all the methods. and you be an expert in all the methods, so that if in case you get stuck in any of the method, you can try the next one and then the next one. And I am going to tell you the order, that which one to try first, and then which one to try second, which one to try third. By the third method, in the worst case, by the third method, you will be able to solve all the questions. What are the three methods? First, the basic concept, the exergic basic concepts that I told you. Second, you can consider to be the eye center. Third, you can consider to be the graphical. These are not in the same order. The order in which you have to try them may or may not be different. As I told you, I will teach that separately. Now, let us first solve this question by the graphical method that we have discussed, and then I will be sharing with you other methods, those methods which we have already covered. Using those methods also, we will solve it. So, as per the graphical method, what is the first thing? You need to identify the different members, for which you have to draw the velocity line, the velocity vector. AB is a member, BC is a member, and this slider is a member. So basically, three lines are going to come in the vector. So it is clearly going to be a triangle, because we have to make a closed one. So let us start by putting the point of zero velocity. Just like whenever we draw any graph, we are drawing two lines. Why are we drawing them like this? Why don't we just draw them like this, right? That this is x axis, this is y axis. Why do we extend them and then we make sure that they intersect at some point, so that the origin is defined? The point of zero coordinate, 0 comma 0, is defined. In a similar way, whenever we are starting the graphical approach of velocity analysis, it is important that you define the point of rest, the point of zero velocity. It is very important that you define it in the very first thing, the very first place. In this case, the point of zero velocity is point A, right? Because this is at rest, it is fixed, given to you directly. B is obviously moving, C is a slider, it is moving, directly given to you in the question. So A is the point which is at rest. So let's mark it as small a. Now what should you do next? Should you draw the vector of velocity of B with respect to A first, or velocity of C with respect to A first? Now, if you look at the diagram, you will say that, sir, we are sitting on A and we can look at B. Obviously, B will move perpendicular to AB. So, we can draw a line which is perpendicular to AB like this. And since A is moving like this, AB is moving in this direction. So, B will move in this direction. So, let us put an arrow here. And this is showing the velocity of B with respect to A. And since A is at rest, so it is telling the definite velocity of B. This is a sample response that any of you can give right now. But this is not the correct way of starting it. Why? Because if you want to find out the velocity of B, how you can do that? Velocity of B is equal to, let me write it here actually, is equal to velocity of B, since A is at rest. In velocity of B, you will say that it is equal to R omega. R is equal to the length of AB itself. This whole distance is R. And then we will multiply it with omega AB. But then you will look at the question, omega AB is not known. If omega AB is not known to you, how will you know that how much is the length of this vector? How will you be able to put an arrow here? How do you know it? What if omega AB is 0? What if omega AB comes out to be 0, or it comes out to be very high? So you have to draw a very long line. Just hypothetical cases I am giving you. Obviously, it will not come out to be 0. Otherwise, the mechanism will not move. But recall, I told you this in the basics, that we were unable to decide the vector line because we were not knowing the value of omega. Recall the explanation that I gave you in the basics for the slider crank mechanism. We were having this mechanism, right? This was A, this was B, this was C. For BC, when we were trying to decide its velocity, we were not able to put an arrow there. How did we decided the arrow? By intersection point, we said that, okay, this is point B, so let's put an arrow here. This is the limit up to which the vector should extend. You are able to recall it. In this case also, omega AB is not known to you. How you can say that this vector will be this much in length, right? You cannot be unreasonable. That is why it is not a good idea to start with unknown vectors, those vectors about which you know nothing. It is not a good idea to start with them. You can start with them. You can draw a line like this and say that along this direction the velocity of B will be there. No problem at all. But try to start from those data, from those things which are known to you. No difference will be there in the answer. You can draw a line like this first, and then you go to the velocity which is known to you, which is Vc. But it is recommended to start with those velocities which are known. It will help you in complex cases, in complex questions. So let us start with this velocity. Now this is the velocity of C. But what velocity? Velocity of C with respect to B, or velocity of C with respect to A? Look, question did not mention any of these. Question just mentioned that this is the velocity of C. And whenever question mentions the velocity of any link, any body directly without saying with respect to what link, then it is telling you the velocity with respect to ground. Means with respect to rest, with respect to zero velocity. So this velocity of C is with respect to this point A, which is at rest, right? And it is given that this velocity is having a definite magnitude, that is also known. So we can draw a definite vector having both ends. It is not like the other vector AB, velocity of B with respect to A. Here we cannot put an arrow on the vector. We cannot end the vector at this point because we don't know the magnitude of omega. So we cannot define our omega's value. But since question has given you a direct magnitude for C, so we can define a definite vector like this. This is point C. And how do we know the direction? It is given to us in the question that it is upwards, right? So this vector is representing velocity of C with respect to A, which is nothing but velocity of C, which is given to you as 12, which is given to you as 12 meter per second. Now you come and judge the direction and the orientation of other velocities, right? It is recommended to plot the known velocity first. So out of the three members, AB, BC and the slider, we have plotted the velocity of slider. Now let's plot the velocity of AB and of BC. The velocity of AB, as we know, should be perpendicular to this link AB, right? What should be its direction? So if you sit on A and if you look at B, it will either look to you going in this direction perpendicular to AB, or in this direction perpendicular to AB. Since omega is in this direction, since omega is counterclockwise with respect to A, so the velocity is going to be in this direction, velocity of B is going to be in this direction with respect to A. So if you are on point A, the velocity of B will look as if it is going in this direction with respect to A. But up to what point? Up to here, here or here? We don't know. Now this vector ideally should be velocity of B with respect to A, which is r omega. R is AB multiplied by omega of AB. The value of AB is known, it is 5. Omega AB is unknown. Omega AB actually is required as an answer of this. So this is what we know, that this vector once established will be giving you the value of 5 omega AB. Alright, let's talk about the third and last member BC. We know that point C on this link BC is going upward with respect to A. With respect to A, it is going upward. That we have already considered. But what will be the direction of C with respect to B? That we have not discussed yet. And that will be equal to, that will be given by drawing a line perpendicular to BC. If you are sitting on B, if you are looking at C, it will look to you either going in this direction or going in that direction. Right or not? Perpendicular to BC. So let us draw a line perpendicular to BC like this, right? So if we draw it like this, now what are the things we know about this line? First, it should be perpendicular to BC. Second, since it is telling you the velocity of C with respect to B, right? So it should pass from C, right? This is the second point. And third point, which I will say a logical point, that ultimately you have to form a closed polygon. And how you can do that? This is the only way in which you can do that. If you want to arrange a line having this orientation in any random order such that you complete this shape, the only way is to do it like this. Whatever other way you choose, you will not be able to complete it. You have to pass it through point C, only then you will be able to close this polygon. So this you can consider as a logical step ahead that is going to close this polygon. Obviously this point is going to be point B, because this vector here, this vector was telling you velocity of B with respect to A, so this point should be B. This vector is telling you velocity of C with respect to B, that also confirms that this point should be B. So we have reached at this state where we have completed this velocity polygon. Now you look at what are the things which are given to you. We know that this AB is inclined at 45 degrees with the vertical. So the perpendicular line to AB will be inclined at 90 minus theta. Theta is 45. So again it is inclined at 45 degrees. If this angle was 60 degree, so this angle would have been 30 degree. If this angle was 50 degree, this angle would have been 40 degree, right? Since this line is perpendicular to AB, basic school level geometry, nothing else. So this line which is going perpendicular to AB will be making an angle 45 degree with the vertical. What is the line perpendicular to AB? This is the line perpendicular to AB. So this will make 45 degree with the vertical. There is one tip that I want to give you here. You can write it down in your notes. Whenever you are trying to figure out the orientation from this diagram and use it here, just like we have done it here, try to decide the orientation with respect to horizontal or vertical. That will be easy for you to understand and plot. If you try to locate this line in this diagram, then in this diagram, and then think of different angles, it may get confusing. In this case it is not confusing because it's a very simple straightforward case. But the best way is that if you have drawn a line perpendicular to AB, and in this case you figured out that this is the angle which it is making, this angle is angle from vertical, just take this funda and use it here. Whatever is the line you are having here, perpendicular to AB, it will be having angle 45 degree with the vertical, right? Directly apply this. Similarly, this is BC. There will be a line perpendicular to BC. Which is that line? This is the line perpendicular to BC, right? BC is forming 30 degree angle with the horizontal. So this is the line perpendicular to BC. Many ways of finding the orientation. You may think that you can do a construction like this. This angle is going to be 30 degree, and since this is 90, so this has to be 60. So you can say that this line will make a 60 degree angle with the horizontal. The line perpendicular to BC will make 60 degree with the horizontal. You can think it like that. So this angle will be 60 degree. This is one way I am telling you, right? What is the other way? Let me draw it here. This is B and C, and I have shown a part perpendicular to BC. Assume that this is also a solid part. Okay. So this BC is our link and this part is perpendicular. Now what we are doing, this whole rigid body where this is BC, this is perpendicular to BC, we start tilting it, we start rotating it. So what will happen? BC has rotated like this. This was B, this was C, and this perpendicular part, obviously it will not stay like this. It will also tilt with BC. When you tilt it, this is a whole rigid body, this will also start tilting. So this part will also reach like this. And now at this point, if I tell you that BC is making theta degree with the horizontal, how much angle will the perpendicular be making, or from the vertical? Imagine a line like this, and this angle will always be theta. You imagine it, when this theta is 0, this theta was also 0. When this theta is 0 means when BC was horizontal, then this theta was also 0, this was vertical. as it will start moving up by theta degree, this perpendicular part will start moving away with theta degree from the vertical. When this theta of BC will be 90, so this is how BC will become, right? This theta has become 90. So this theta also from the vertical has become 90. Remember this funda. This will help you quickly determine the angles. This is not a tip for mechanical engineers. Basically, these tips are given in schools, but still it can save your time here, right? So if BC is having 30 degree with the horizontal, its perpendicular will also be having 30 degree with the horizontal. So if this is the horizontal, this is 30 degrees. This is 30 degrees. Now if this is 30 degree, this also needs to be 30 degree, right or not? Because this is also vertical, this is also vertical. This line is intersecting two parallel lines. So they are alternate interior angles. I think this was the name which was used for them. So this is 30 degree, this is also 30 degree. So now in this triangle, we have this angle 45 and this angle 30. So there's sum, this plus this should be equal to 180 degree. So this angle will be equal to 180 minus 45 minus 30, which will give you 105. So this angle is equal to 105 degrees. So we have determined all the three angles. One side is also known to us, and now we need to find out the omega of AB. The omega of AB can be calculated if you know the velocity of B with respect to A. But if you can determine this value, then you can determine the angular velocity of BA or angular velocity of AB. Both are one on the same things as far as magnitude is concerned. So how much is the magnitude divided by how much is the length of VB, right? It is nothing but V is equal to R omega. Same expression has been written. Again, I'm telling you, this is something that we are going to discuss in detail. I'm not going into this expression right now, but I think this much basic idea you can have from V is equal to R omega, that this is how this expression should look. The reason why I picked this question was to prevent you from this mistake, that without knowing omega, don't try to put the vector on the other end. That is why I give this example where omega is not known. This is the reason behind it. This is not the reason why I gave this question. You can easily do it. If not now, don't worry, stay with me. After a few videos, you will be able to totally understand all the things behind this expression. And it is an interesting expression. I will tell you the details. Okay. So what we can understand right now is that AB is known to us, which is 5. The velocity of B with respect to A can be calculated from this particular velocity polygon, and you can divide it to find out the angular velocity of BA. Now, since we have done this much of hard work, so let's complete the question. If we apply the sine rule in this triangle, then sine of 105 divided by the side opposite of it. What is the side opposite? This one is the side opposite of it, 12 meter per second. This is equal to sine 45 degree divided by the side which is opposite to 45. In this triangle, you can clearly see this side is opposite of 45, which is velocity of B with respect to C. This is equal to sine 30 divided by which side? This side, opposite of 30 degree, which is velocity of B with respect to A. So this, if you equate with this one, then what you can find out? You can find out the velocity of B with respect to A. Then you will get sine 105 degree divided by 12 meter per second is equal to sine 30 degree divided by velocity of B with respect to A. If you put the values and if you solve it, you will get 6.212 meter per second as the velocity of B with respect to A. Now what you need to do? Simply put the value here. So you will get omega of B A is equal to 6.212 divided by AB. How much is AB? AB is equal to 5. Put it, you divide it, you will get the answer as 1.2424 radian per second which is the required answer for this question. So the case that we discussed here was a very basic case. Still, I took that much time to explain it, so that I keep giving you different tips as well. I give you geometrical tips as well. I gave you the tips regarding how to start and from where to start analyzing any mechanism graphically. And I also told you what mistakes you have to avoid while drawing the graphical curve for any case. But there are still more concepts, some advanced concepts to understand for graphically analyzing the velocity of any mechanism. Let us see those cases with some advanced mechanisms.